Welcome everybody. I'd like to give you a short tour and demo of our PCAP serializer, deserializer for Apache Hadoop Hive, which is a data warehousing application. And in order for you to be able to reproduce that results very quickly, I'm going to use Amazon Web Services Elastic MapReduce, which is essentially just Apache Hadoop with supported by Amazon to run directly on their EC2 cloud services. To get started, I downloaded the PCAP SerDE jar from our website, and now I'm just going to go to AWS Amazon.com. On that site, you'll notice that there is a link to the management console on the top here. So I'll quickly do that. Now I'm logged into the console, and on the left hand side you can see the Amazon S3 storage service. And in order for us to have some nice data to crunch on, I've uploaded a couple of KRoot PCAP data here, and we're going to use that later on. So we have here about 590 gigabytes of data, and now to start the actual Elastic MapReduce, I will go to Elastic MapReduce. Here you can see I've already ran a couple of jobs in recent days just to get things tested. Now I'm choosing the EU West region here. You should probably use whichever region is closest to where you've chosen to have your data stored in Amazon S3, which essentially is in the EU or in America. If you have it in the US, it just makes sense to run your EC2 instances there as well, because you'll benefit of the lower latency that this will incur. Now I'm getting started by just creating a new job flow here. So you can name that whatever you want. I'll call it PCAP SerDE demo, and I'll choose the job type to be a Hive program. There are two options on the parameter side here. You can either say you want to execute a Hive script. Hive script is essentially just SQL-like statements that you run, and the interesting part here is if you have a job that you want to run continuously or like every week or so, you might want to just put that in a script, and you can just start an Elastic MapReduce job which will run, spin up your instances, and once the job is finished, it will just put the output data, so the result of those SQL statements, into a S3 bucket, and it will just shut down the instances. So you'll use the exact amount of time that you need to process this, no more, no less. In our case, we're going to do a demo, so we're going to use an interactive session just so that we see how it works in general. Here on the EC2 instances side, you need to decide how large you want your cluster to be, and EC2 offers you a large variety of different virtual instances. Those virtual instances range from having a lot of memory to a lot of CPU, and you can basically combine those here. So the number one here is the master. You can just leave that as a small instance. The master in Hadoop is really just basically taking care of registering all the worker nodes and orchestrating all of that. On the other side, on the core instance group and the task instance group, you can choose. The core instance group will be data nodes that will actually store data but also do processing. And if you want nodes that only do processing, you can use the task instance group for that. If you're not quite sure about which sort of size you want to choose here, they are of course different priced, and so the best is if you actually instance types, if you actually want to look at the EC2 instance types, you get the overview here, and in that overview you can also see that they have a huge difference in which sort of memory they have available. And important to note for using it in a Hadoop MapReduce context is that the Elastic MapReduce will allow as many parallel jobs to start on the instance, on each and every instance, as many cores there are available. So in our case, that basically means if we choose larger instances here, we can just run more jobs in parallel right on there. So you have to decide based on the pricing whichever instance serves your needs best here. In our case, we found out that if we use spot instances, I'll come to that in just a second, the high CPU instances in the medium range are actually quite a good fit. Now I'll show you how we go about this. We use spot instances. The reason for that is with spot instances you can actually bid on prices in the EC2 cloud, and with those spot instances you have to bid on a price that is high enough for you to hold those instances. It basically means if you bid on a low price, you might have the market currently working for you, so you will get those instances right now, but if the price goes up, Amazon can actually kill away those instances for you. This is not much of a problem if only a few instances go away, because Hadoop automatically takes care of actually rerunning those sub-processes on other nodes. So in our case, we said that the medium range works quite well for us, and I'm going to use 100 instances here for this job to just show how nice we can actually make really long running processes work here. In order for me to know which spot bid price I should use, I'm going to actually use another management console to see what the current pricing for those instances is. I'm going to basically bid a little bit above this price. Especially for this demo here, we're not going to have a very long running job, so there's no need for me to do any competitive bidding on the pricing. Notice that spot pricing basically allows Amazon to sell currently unused capacity in the cloud, and because of that you get the capacity way below the normal on-demand price. Now I went into the management console onto the EC2 tab, and I can find the spot requests area here. Here you have a nice pricing history graph which you can open. I'm going to change to the C1 medium type that I used before. Takes a little bit to load. You can see there's quite some variance in some of those, and the medium type at the moment has quite a stable price, which seems to be around 0.8 US dollars. And so we should be quite safe by bidding for something like 0.9, and so that's what I'm going to do here. I'm going to bid for 0.9. I'm not going to use any specific task instance groups here, because I'm basically going to have data and computing all the same nodes. Now if we advance in this dialog, you get a couple of options here which, if you need to debug something, can help you out. We don't need any of this for now. Also no bootstrap actions to modify how those instances will spin up. And then we'll create this job flow. When we create this job flow, that essentially means that now it will create all of those spot bidding prices, and that can actually take a little while. So we're going to have to wait until we actually get all of our instances spun up. If you want to follow that progress, you can change onto the dashboard is best, and you can see we currently have 23 instances running here already, so I expect that to go up to 123 once we have everything running. Actually 124 including the master. Okay, I've been refreshing this dialog for about the last 10 minutes, and you can see that slowly we're getting the instances allocated for us. It really depends on how the current spot pricing market is. It could be faster, it could be slower. If you have no need to save a lot of money here, or if you just are doing test runs and just want to do a quick check on this, you might want to use on-demand instances to save yourself time from waiting here. But other than that, the spot instances should be here within a second. Now If we look at the dialog here, we have a couple of our other instances around. If I reload this now, I'm going to notice we have a lot of instances here now. We're at 124. We had 23 before, so 101 instances. The master plus 100 worker nodes have been set up. They're all running now. There might be still some spinning up. It seems that we have all running now. In order to actually log into the system now, you're going to have to identify the master node, which you can see once it's the one in the security group Elastic MapReduce master, and it's the only one of them that actually has the type of M1 small. I'm going to get the public DNS name of it, and we're going to SSH into it. When SSHing into it, it comes in handy to create a couple of port redirects. I'll show you in just a sec for what they are. And the username for which we log into is Hadoop. Okay, so I have already loaded my SSH key pair that I defined when starting the system up, and you can see that the SSH is logging in, and after the login dialog you can see that there are those two job tracker and name node URLs here, and that's why we created the port forward, so that instead of using links on the system we can just use our browser here and go to those URLs. And you see that here this is the MapReduce administration, shows 100 nodes that it has available, and our this is our HDFS file system, also has 100 live nodes, which brings our total capacity to 31 terabytes on this cluster right now. Here are all our nodes, and now we're going back here. On the system, I downloaded the jar file from our website before. I'm going to SCP that onto the system. Okay, so now we have this jar file here, and in my browser I'm going to go back to the S3 dialog so that we can find the bucket name that we're going to want to run our test against. So essentially here now I can just execute the command Hive, and from here onwards there's no difference between running this in Elastic MapReduce on Amazon's cloud or if you have your own installed Hadoop cluster with Hive. Now I say add jar and I add this jar. That's just because this is not a standard library. Now here in this text editor I've prepared a create table statement, and we'll go briefly through it. In this case I'm not using the DNS specific, but I'm using the simple PCAP input format. That input format currently supports these fields, so the timestamp, the protocol, source port, destination port, the length of the packet, and the TTL of that packet. The rest here is we specify which serializer deserializer we want to use from our jar file, and the input formats. There is no output format, so we give the Hive ignore key text output format class because we don't support any serialization, we only support deserialization of PCAPs at this stage. Now I need to change the S3 URL here to reflect the actual bucket name. This bucket name I can find in my management console. I'll copy that name here and insert it here. I'm going to create a table specifically for the M6 dataset, and now I'm going to get the first 10 PCAP or the first 10 packets in those PCAPs. This takes a little while, so MapReduce is not about fast response times, it's about having large computational tasks split and distributed amongst a lot of systems. So especially small queries like that take a little while. Now before I go further with this, I want to show you what we're about to do is we're going to crunch So I'm going to show you how much data we're actually going to process here. So here you can see that we have about 80 gigabyte of M6 data that we're going to process. Going back into Hive, always after you quit Hive, it forgets about the library that you added. So you always have to do the add jar, or you create an RC file for that. Now on this M6 data, I'm going to do a query. I'm going to say I want to know which as queries, which source address is sending me the most queries within this time frame. From PCAPs group by, you can see that this is very similar to your regular SQL syntax. I'm going to order it by queries descending, and I'm only interested in the first, let's say, 25 of them. Once you execute this, this will actually now translate into MapReduce jobs. To start those up, it takes a little while. The reason for that is that it has to get the directory listing first, and once we actually have the first MapReduce job starting, we're going to see that here in the running jobs. Should take about less than 30 seconds, I think. Okay, the first job has been dispatched to the Hadoop cluster, and we can see it running here now. When we click on this, we get some details on it. You can see that there are going to be 1012 actual map tasks here, and 400 of them are running, because that's our limit of the maximum of them running in parallel. And here we can track the progress of these. And you can see running 400 of those in parallel is a huge benefit. There are other systems like PacketQ which you can use to do similar SQL-like queries against PCAPs, with the downside being that those have to run in sequence. So we're about 1/4 of the map tasks of this job done now, and it's been less than 1 minute. So we've processed about 20 gigabytes of data right now. Okay, we're coming to the end of this first job. When you're up here, you can see that there will be a total of 2 MapReduce jobs. That essentially is up to Hive to decide how many MapReduce jobs it needs to run in order to fulfill your query. Whereas you can see that the initial stage will be to basically group down the records, and so consecutive MapReduce jobs will just get smaller and smaller and process faster. So the second one is now launching, which launched within a couple of seconds, and I expect that to finish pretty quickly. Once all of the jobs have finished, we'll just see the result straight here on standard out. And you have the result here right now. We see that the highest rate is where the source was actually null. This is due to the current limited support in our PCAP SerDE. It doesn't actually support decrypting, deserializing all sorts of packages, so some of them will just return with null. And this here is the kroot IP itself, so those are the response packets. And once we've sieved those two out, we can see the actual top query in this time frame was this one here. And that's about it for running Hive queries. Some other nice things to note about Hive is that if you run this on an internal cluster, you could also consider integrating Hive with a standard JDBC, which is the Java database interface, and it will just basically look like any relational database, but process large chunks of data in the back using standard Hadoop MapReduce. So for my tutorial, that's about it, what I wanted to show you. Once you're done with your cluster, don't forget to shut it down in the Elastic MapReduce panel here. So here you just say terminate, and that will bring down your cluster. Note here we ran the cluster for only 15 minutes, so this will be rounded up to full hours. So we ran a total of 101 instances for 0.09 maximum price. So this is the price we're going to pay for those instances. We'll have to add the cost for on the medium scale. Oh, made a mistake here. And a little bit for storage. So you can see that the total price for doing this computation here is less than $20 and it took us 15 minutes on the actual processing. And once you have the setup scripted, it takes you less than half an hour to do some computation on a 80 gigabyte data set of raw PCAPs. So I hope you found this screencast useful, and I'd appreciate some feedback on it. Thanks.